Hello, PreCalc. We've got day 2 of section 5.3. We left off with example 6. Find all solutions of sine of x plus 1 equals cosine on the closed interval 0 to 2 pi. Okay. So we have mixed trig functions, not cool, and they're not squared, so we can't use any of our identities yet. So here's what we're going to do. Step 1 is we're going to square both sides in an effort to get a sine squared and a cosine squared, and then we can use our substitutions. Okay, so sine squared plus 1, or sine plus 1 squared. Alright, if you need to multiply that out on the side, FOIL it out. Hopefully we can square a binomial at this point in our math lives. Sine times sine is sine squared. Sine times 1, we got plus sine, plus another sine. 1 times 1 is 1. So it's square the first, square the second, multiply the middle two together, and double it. So we should have sine squared plus 2 sine plus 1. Alright, so that's what we got over here. Equals cosine squared. Alright, our cosine squared substitution is 1 minus sine squared. And then now we should have all sines, and that's good. Alright, let's move all of this to the left. Plus sine squared. Minus 1. Okay, so we got 2 sine squared plus 2 sine 0 equals 0. What can we pull apart? They both have a 2. They both have a sine. 2 sine on the outside, sine plus 1 on the inside. Okay, let's think about that. When would this equal 0? 2 times sine. When does 2 sine equal 0? 2 sine equals 0. Well, you divide by 2. When does sine equal 0? 0 and pi. Alright, we'll come back to this in just a second. Okay, when does sine plus 1 equal 0? When sine equals negative 1. Where does sine equal negative 1 at? Down there at 3 pi over 2. Okay, so we're thinking, hey, we got 3 answers. 0, pi, 3 pi over 2. Alright, good idea to double check, because we did some switcheroos here from sine to cosine, and sometimes you get some sign errors by doing that. Okay, so let's check. If x equals 0, x equals pi, and we had 3 pi over 2. Okay, so if I put that into my original equation, we will get, well, we can go a long ways here. Sine of 0 plus 1 equals cosine of 0. Okay, sine of 0 is 0. Plus 1 is going to be 1. Cosine of 0 is 1. That one works. Good. At pi, alright, sine of pi is 0. 0 plus 1 is 1. Cosine at pi is negative 1. Not the same. No. And then 3 pi over 2. Sine at 3 pi over 2 plus 1, does that equal cosine of 3 pi over 2? Sine of 3 pi over 2 is negative 1, plus 1 is 0. Cosine of 3 pi over 2 is 0, so that one works. So our final answers are 0 and 3 pi over 2. Again, we had to double check those because we are switching sines and cosines around. All right, on to the back. Functions involving multiple angles. All right, so if you have a multiplier on your theta or your x, or I guess your t in this case, what do you do? Okay, we're going to pretend that it's a normal one first, and then we're going to divide by whatever our multiplier is. You'll see here. Okay, so piece of cake here, solve 2 times. The spacing on these is just terrible. It's very misleading. Let's solve 2 times cosine of 3t minus 1. So you're going to add the 1 over. And now we have 2 cosine. And now I am going to have to write my x's or my t's or my thetas because they are needed. 3t equals 1. Okay, then you're going to divide by 2. 1/2. All right, so we're going to temporarily pretend that we're done. We're going to temporarily pretend that we're done. All right, where does cosine equal positive 1/2 at? Pi over 3. 5 pi over 3. Okay, pi over 3 and 5 pi over 3. So now we're going to take into consideration the 3t part. So normally we would say, oh, it was pi over 3 plus 2 pi n and 5 pi over 3 plus 2 pi n. All right, and we're going to have to divide by 3, everything by 3. So that's going to give us t equals pi over 9 plus 2 pi n over 3 and 5 pi over 9 plus 2 pi n over 3. Okay, we're going to temporarily pretend this is like just regular cosine of x or something like that. Equals 1/2. Oh, cosine of x equals 1/2. Where does that happen at? Pi over 3 and 5 pi over 3. Oops, wait a minute. I didn't have x. I had 3x. So now I have this all set up like I did before, and now I'm going to have to divide everything by 3 at the end. Not a big deal, but you just have to remember to do it. Find all solutions of tangent of x over 2 minus 1 equals 0. So we got tangent of x over 2 equals, add that over, 1. Okay, tangents can be tricky, but they made it a nice one. Where does tangent equal 1 at? So for tangent to equal 1, sine and cosine have to be the exact same thing. All right? And that's going to be the 45s or the pi over 4s. So pi over 4, we have positive radical 2 over 2, positive radical 2 over 2. If I would divide those, I'd get 1. Okay? 3 pi over 4. All right, it's split. We got a negative and a positive, so when I divide those, it's going to be negative. 5 pi over 4, we got negative, negative, so that's going to be positive. And that's one we want. And then 7 pi over 4 is positive, negative, so that is not one that we're going to want. That would equal negative 1. Sorry for the pause. Let's see how we're doing. Okay, so we said we wanted pi over 4. And we wanted 5 pi over 4. But wait, pi over 4 and 5 pi over 4, they're directly across from each other. So I can kind of combine those into one. Pi over 4 plus pi n. Okay? Pi over 4 plus pi n. All right? Now this was x over 2, so we have to actually multiply everything by 2 here. Okay? So now we're going to have pi over 4 times 2. That'd be 2 pi over 4. That's going to be pi over 2. And 2 times pi n plus 2 pi n. All right? Okay. And then this one is kind of just a little bit out there. I'm not sure if this is going to be on the quiz/test or not. This one's kind of a little bit out there. But we'll talk about it at least. We'll talk about it. All right, solve secant squared of x minus 2 tan x equals 4. Okay, so this is another one where we got mismatched. So we're going to substitute. Remember, secant squared equals, you might have to rearrange your formula. Secant squared is going to equal tangent squared plus 1. So I have tan squared plus 1 minus 2 tan equals 4. All right, we're going to rearrange tan squared minus 2 tan. Okay, I had a plus 1. If I minus the 4 over, it's going to be minus 3. Okay, we're going to use our factoring. We're going to use our factoring, what multiplies to negative 3 and adds to negative 2. Negative 3, positive 1. So we have tangent minus 3 and tangent plus 1. Okay, let's take care of this one first. The tangent plus 1. Where does tan plus 1 equals 0? Well, that's when tan equals negative 1. So that's almost opposite of what we just did. So I don't want those because that's a positive 1. I do want this one because that's negative 1. No, negative over negative is a positive. Yes. And so I want 3 pi over 4 and 7 pi over 4. And again, those are straight across. So we can do 3 pi over 4 plus pi n. Okay, and it says using trig inverses or inverse functions. All right, so it wants exact answers. When does tan equal 3? Oh, let's go the long way. 10 minus 3 equals 0. Add the 3. When does tan equal 3? You don't really know. It's going to be kind of ugly. It's not going to be one of our nice ones. So what they do is it's the tan inverse, or arctan. Arctan of 3, and it's plus pi n again. Why is it plus pi n? Okay, it's plus pi n because, like the last couple times that you're like, oh, they're just straight across from each other. Well, remember the period for tangent and cotangent is different than sine and cosine. The period of tangent and cotangent is only pi, and that's why these repeat. So we're going to do a plus pi n because the period for tangent is just pi. All right, like I said, that one's a little bit out there. It's just because it wants an exact answer. If you did tan inverse of 3, it's not going to be a very pretty number. Let's see, just for visual purposes here. Plus, we're also talking radians, so it's also not going to be very pretty there. Let's just look at it in degrees, because that might be a little bit easier to kind of figure out and then transfer that into radians. So we want tan inverse of 3. 71 point, see, it's not going to be very pretty degrees, which means it's even going to be it's going to be less pretty in radians, okay? So that's why they leave it like that. All right, folks, thanks for watching. Finish up that homework, and we'll see you later.